In this problem, we're asked to show a few inequalities. The first inequality we need to prove is that probability of A plus probability of B minus 1 is less than or equal to probability of A intersect B. So we're going to use a couple properties to show this, properties and axioms of probabilities. And one axiom we're going to use is the probability of the sample space equals 1. Another property we're going to use is that if A is a subset of B, then probability of A is smaller or equal to probability of B. So one more property we're going to use is that the probability of A union B is the probability of A plus the probability of B minus the probability of their intersection. So the left-hand side of this inequality, we can rewrite the inequality in the following way. We can actually subtract probability of A intersect B from both sides to get A plus probability of B minus probability of A intersect B less than or equal to, and now we add 1 to both sides. So the left-hand side of this inequality is probability of A union B, and we know by the second property that this is going to be less than or equal to 1, because 1 is probability of our sample space and A union B is a subset of our sample space. So we see that this inequality is true. Now the inequality becomes a strict equality when A union B is our sample space. In this scenario, we see that the probability of A plus probability of B minus probability of the intersection is going to be equal to 1, because again, this left-hand side is the probability of A union B, and if we assume that A union B is our sample space, then its probability is going to be equal to 1 by the axiom of probability. Now, the second inequality we're going to show is that probability of A intersect B is less than or equal to probability of A union B. Well, this again, this follows exactly from the second property of probabilities, because A union B is a subset, or rather A intersect B is a subset of A union B. And so that implies that the probability of A intersect B is smaller or equal to probability of A union B. And when will this be strictly equal? This will be strictly equal if A equals B, because if A equals B, then A intersect B is the same as A union B. So their probabilities will be the same. And finally, the third inequality that we need to show is that probability of A union B, probability of A union B is less than or equal to probability of A plus probability of B. Well, this flows directly from this third property here, because we know that probability of A union B equals probability of A plus probability of B minus probability of the intersection. And so this expression here is going to be less than or equal to probability of A plus probability of B. And the only time where we're going to have a strict equality is if probability of A intersect B is 0. So in other words, A intersect B is the empty set.